Well, it's time to culminate the subnetting topic as we look at the final method, variable length subnet masking. And I know some of you might be looking and going, well, there was 4 examples with the other one. What's up with the one example? Well, trust me, when you see it, you're going to be like, okay, I only want to do one of those because it takes some time. And really, all VLSM is using the skills that you've learned in all the subnetting we've done up till now, and just kind of squishing them all together. I won't say there's not really any new subnetting topic that we talk about, just kind of applications of what we've already seen. And here's the concept. Let me explain the concept, and then we'll get into the example. The concept is simple. It's changing your subnet mask whenever and wherever you want. So, for example, we've been doing so far in all of our subnetting what I would consider kind of like classful subnetting, to where we find one subnet mask to rule them all. We say, okay, I want 50 networks, and we break it up, and there's our one subnet mask that rules them all. Or I want 20 hosts per network. There's our one subnet mask, rules them all. We just find one subnet mask. But in looking at the examples, you've probably seen situations where, well, this office has 50 users, and this office has 10 users, and our WAN link has 2. I mean, there's 2 devices right there. So finding one subnet mask to rule them all might not be the best way to go, because we'd have to figure it out based on the largest subnet, right? But then if we're finding it based on that, then using that subnet mask here wastes a whole bunch of IP addresses, and same thing here. So VLSM is really just saying, well, I want to find one subnet mask for that network, one subnet mask for that network, and then pushing it all together. So now let's move into our example of VLSM. Take this network environment. We've got 3 networks, well, I'll say 3 user networks of 20 users, and 60 users. And then we've got 3 networks of WAN links that we can't forget about that would have, what, two devices each, right? So here's our scenario, and this is how you'll be able to tell if we're getting a VLSM question. It says subnet 192.168.1.0/24, so class C. To address this network, here's the key: use the most efficient addressing possible. That immediately tells you, okay, we want those subnet masks to be efficient. We don't want to waste IP addresses if we can. So the key behind subnetting, or VLSM, is to do the same things that we've been doing, but if we want to be efficient, start with the largest subnet first. Okay, largest subnet. What is it on the screen? Identify it. This guy right here. 60 users. So it's using the same methods that we've seen. So step 1, and I'll go a little faster because we've seen them in the previous nuggets. Step 1 is to convert that number to binary, or more specifically, find out how many bits that number needs to be represented in binary. So I'll throw our binary chart down here: 128, 64, 32, 16, 8, 4, 2, and 1. So 60 in binary is going to be, let's see, 0, 0, 1. So immediately I can stop there, because I know that 60 is going to take 6 bits. Remember, I can't get the number 60 with any less than 6 bits. So step 2. We say, okay, reserve bits in the mask and find our increment. So I'm going to say our mask originally was a /24, right? Which is 1, 1, 1, a whole bunch of ones, 24 ones, dot, and then 1, 2, 3, 4, 5, 6, 7, 8. The zeros I want to write out because that's my playground. This represents the first 3 octets of 24 bits that are there. Okay, so reserve bits in the mask and find our increment. Now, so I'll ask the question: are we creating more networks? Is our focus on the networks, or are we saving the hosts? Saving the hosts, absolutely, because we're focused on 60 users, not 60 networks. I need 60 users, 60 IP addresses on this network. So I'm going to go right to left: 1, 2, 3, 4, 5, 6, and the rest can go. Whoa, 7, 8. Did I? 1, 2, 3, 4, 5, 6, 7. No, I must have just wrote skinnier or something. So we've got this is our new subnet mask for the network. So if we were writing bit notation, it'd be /26, or decimal 255, 255, 255.192 would be what this is, converted back to a decimal number. So that's what our subnet mask is for that network. That's my emphasis. Our subnet mask for that network. So now we find our network ranges. Oh, wait, our increment. Lowest network bit converted back to a decimal number, 64, right? And that makes me feel good because I was after 60 users and I got the number 64 as my increment. So step 3, we start off with 192.168.1.0, and then we just start adding 64. 192.168.1.64. Now, stop the train right there. Let me ask the question. How many networks of 60 do we need? Look at it. Just one, right? That's it. That's the only network of 60 that I have. So I can stop right there because I got my one network of 60. It's this one. 192.168.1.0 through 63 because the next network starts at 64. So I'm done. Now, what I've done is created a unique subnet mask for that network. Let's write it up there. So I'm going to say, let's go blue. Let's go red. And get the right pen. 192.168.1.0 through 63/26. Now, I write it this way because I like to see it, but know that that's not a standard. You don't see that, that they'd be like, hey, that's not a standard way of writing it. I like doing that because I can see the range and the subnet mask all at the same time. So that tells me what that network is. Okay, great. So take this, put it into a little box, and do it again. What's the next biggest network that we have? 20 users, right? So let's just jump up top. I like keeping them both on there because I want to show you how this works. So 20 users, if I do that, how many bits to get the number 20? No, no, no. Yes. Okay, so line moves over. It takes 5 bits to get the number 20. Okay. Step 2, reserve bits in the mask and find my increment. Same subnet mask, nothing different here. It's as if we had never done subnetting yet. So /24 is a whole bunch of 24 ones, dot 1, 2, 3, 4, 5, 6, 7, 8 zeros. So now I'm going to say, okay, am I creating more networks or saving the hosts? And the answer is, we all scream, saving the hosts. We need to save 5 bits of host bits. Otherwise, I can't get the number 20. 1, 2, 3, 4, 5. 1, 2, 3 left over. That's our new subnet mask. /27 or 255.255.255.224. So those are 2 different ways of writing the subnet mask. Our increment, let's grab green here. Our increment is going to be 32. Which again makes me feel good because I'm like, okay, 32 is bigger than 20. So step 3, okay, here's where it gets a little weird. Find our network ranges. Okay, so 192.168.1.0, .1.32, .1. Okay, wait a sec. We're getting our increments, and I look. I need 2 networks, 1 and 2 of 20 users. But do you see any problem here? The first 2 overlap with this. If I fill in the n ranges, this goes through 63. The first 2 overlap with this. This is the only thing different with VLSM. I look at those first 2 and I go, I'm sorry, I can't use those because they're overlapping. They're already used. So I guess a better rule to say, a better way of thinking about it is rather than just writing these and doing that, you just pick up right where the last one left off. So I didn't have to write this. Now, I did because I wanted you to see it, but I could have just started from 64 and felt safe doing it. That's the beauty of the powers of 2. If I count by 128s, 64 is going to hit every value, right? If I say 0, 128, 250, I guess 256 would be the number. Then if I count by 64, I'm going to have 0, 64, 128. I'm going to get there, and then 192, and then 256. I'm always going to hit the same value. And then if I count by 32s, I'm going to get 0, 32, 64, 96, 128. You're always going to line these things up. You're always going to they're all powers of each other. They're all powers of 2. So you're always going to. So that, I'm showing you that. You're like, what's the point? I'm showing you that so that when you do this and you find your one range and you say, okay, that's where the next one start. As long as you begin with the biggest subnet, you can always feel safe starting there. Just saying, you know what? I don't even have to write that. I'm just going to go 192.168.1.64, and then I start adding 32 to that. So 96, 1.128, and I would say, okay, well, I can stop there because I got my 2 ranges. 64 through 97 is my first one. 96 through 127 is my second one. Yeah? Are you seeing how this works? So now I've done my second subnetting problem. Let me just clear off a little space on here so I can look nice and clean. So I've done my second subnetting problem, and I can come here and say, okay, well, this one, let's go back to red. This one is 192.168.1.64 through 97/27. That's this network. And this network over here is 192.168.1.90. What are we at? 90. Wait. What am I doing? What witchery is this? And I can't count. 97 is, that's not good. I know some of you are like, what's Jeremy doing now? No, this goes through 95, right? 95. My goodness. All right, hang on. Little dissection here of some bad numbers. So 97, so this is actually 95, right? So this one goes from 96 through 1. I'm making sure 127 /27. Does that feel better? I know. Okay, I'm sure I disturbed a number of people by doing that. Okay, so that's this network. Now before we do the last piece, because there's one more. It's the WAN links, right? First thing I want to say, I want to ask you, are you getting it? Are you kind of seeing how this works? And you see why it only takes one example. You're kind of like, okay, I get it. It's multiple subnetting problems all in one. That's what VLSM. But I want to ask the second question that I get asked quite a bit. A lot of people that are certification minded are like, how do they even ask a question like this on the exam? Like, I mean, obviously the exam is a series of multiple choice, drag and drop, simulation, all that kind of stuff. How do they ask a question like this if they were going to ask me to do VLSM? What will typically be used is drag and drop, to where what you'll see is a diagram just like I'm showing you right here, and then you'll see a whole bunch of boxes. And they'll just have subnets, all these subnets. So one box will be like 192.168.1.64/27. One will be dot 96/27. And you actually have to drag and drop those boxes to the specific areas of the network where they belong, and you just kind of plant them there, and that's how it knows whether you got the right answer or not. So now, and also keep in mind, the test is geared. It's smart enough to know, for instance, these two are interchangeable. I could have put 96 through 127 over here, and I could have put 64 through 95 over here, and that's totally fine. That's not a problem. So good. You ready to do the last piece? Let's see where we can squeeze it in, because I like keeping them all on there so you can see what we've done. Let's go small. So I'm going to go down here 1. So the last thing is we need a few networks for our WAN links of 2 hosts each. So let's start there. 2 hosts. What's the binary equivalent of 2? Right there. 2 bits. To get the number 2, I need 2 bits. So step 2, original subnet mask /24 equals a bunch of 1s, 24 1s. 1, 2, 3, 4, 5, 6, 7, 8 zeros. So I say, okay, I need to reserve my bits in the mask, and I'm going to save the hosts. I need two hosts per network. 1, 2 are saved. 1, 2, 3, 4, 5, 6. Flip over to the network side, the dark side. I now have a /30 as my subnet mask, or I'm not going to write, well, let's write over here. 255, 255, 255, 252 is the subnet mask that is. So again, two ways of writing the same thing. So I'm going to come over here, and I'm going to say my lowest network bit, convert back to a decimal. That'd be 124. That's a 4. So now my network ranges will go up here. How's that? So I'm going to start off with 192.168.1.0, right? And I just start counting by 4s. 8, 12. Now, stop the train. That's going to take a while, right? Because I look at all these, 0 through 3, 4 through 7, 8 through 11, and all as I go down. That's going to take some time because these guys are all used up. They're overlapping with this range or these ranges. I mean, I would have to count by 4s down to 128. Or what if we just went ... 192.168.1.128. Like I said, if you count by 4, you're going to hit every increment of 16, 32, 64. You're going to hit all those. So it's very safe to say we left off at 128. Let's start there. 128, 132, 136, 140. Now, how many networks do I need? 3. Good. I got them. 128 through 131. through 135 through 139. So now I can go line these guys up. So top link, top WAN link is going to be 192.168.1.128 through 131/30. Over here, 192.168. Hang on, let me just write them all up. Okay, there. I've written them all up. So I've now created networks for each one of those WAN links. Let me just put an arrow there. Now you might see, on the exam, something that has you drag the networks just like I've done, and kind of, this would be your empty boxes, and you would drag the networks in there and label them. Other ones might actually have you assign them. So, they might say, okay, this side would be .129, this side would be .130, so those are the two usable IP addresses from that network. Or over here, our default gateway might be 192.168.1.97, the first valid IP address from here, and that's what everybody points to as their default gateway. Maybe the computer. Computer can be anything, but we'll do .1. I'm out of room. 98, slash 27, as the subnet mask. So it depends on how that works. What the question is looking for. Many different ways of asking it, but do you see how we've done that? Isn't that amazing though? If you look at it, we've addressed this whole network and barely gone over half of the total IP addresses that we have. That's the beauty of VLSM. Now let me ask this question. What if I said this is 60 users, but look, our subnet mask only allowed for, what is that total, 62? What happens if this office grows and they hire 5 more people? Dope! You're hosed because you explode your whole scheme, right? You just outgrew the subnet, so now you're like, that's where it just gets ugly. So while VLSM looks awesome on paper, and don't throw the baby out with the bathwater. The VLSM is awesome and it's used all over the place, but it's not used in such a way to put your subnet so tight that there's no room for growth. You want to allow room for growth, but you just don't want to be at a place to where you're forced to waste IP addresses because of these giant subnets you had to create for one area of your network. So do you see why I said we'd only need one example of it? VLSM really isn't anything new. It's just doing what we've already done again and again and again and again. I think the newest thing is just to say, you start with the biggest subnet, and kind of work your way down so that you get efficient use of your IP addresses. But that is it. That's the culmination of everything subnetting. The cool thing is, at this point, there's nothing that somebody could throw at you from IPv4, from normal TCP/IP, where they're like, "Hey, check out this subnetting." You've seen it all. You've seen the binary behind it. You've seen how to do it on networks, on hosts, reverse engineering, and then finally getting super efficient using variable length subnet masking. The only thing that I would add to this is truly classless. not like you're a lesser person, but this is truly classless IP networking. There are, as we dive into routing and get into routing protocols, there are some routing protocols, old routing protocols like RIP version 1 and things like that don't do this kind of thing. They don't have the ability to do variable length subnet masking. They can do subnetting, but once you find that one mask, they have to use that for everything. But that being said, nobody uses those protocols anymore. So this is now a normal way of life. Well, I hope this has been informative for you, and I'd like to thank you for viewing.